Hello everyone, and welcome to my channel. Here, we explore the fascinating world of science, from the mysteries of the universe to the wonders of everyday life. Sit back, relax, and let's discover something amazing together. When we look up at the night sky, we often see countless stars scattered across the darkness. Yet hidden among them is something far greater, a vast cosmic system that contains our Sun, our Earth, and everything we have ever known. This system is called the Milky Way galaxy. The Milky Way is not just a beautiful band of light in the sky. It is our home in the universe. It is a massive, dynamic galaxy filled with hundreds of billions of stars, planetary systems, and mysterious forces that shape its structure and evolution. Understanding the Milky Way helps us understand where we are, how we came to exist, and how the universe itself continues to change. In today's presentation, I will guide you through the Milky Way galaxy in 8 parts. We will explore what the Milky Way is, how it is structured, where our solar system is located, how the galaxy moves and evolves, and why it is so important to modern science. Along the way, we will also discover some surprising facts and look toward future explorations. By the end of this presentation, I hope you will see the Milky Way not just as a distant object in space, but as a living system that we are deeply connected to. When you look up at the night sky on a clear evening, far from city lights, you may notice a faint, milky band stretching across the darkness. For thousands of years, humans have wondered about this glowing path, weaving myths and stories to explain its presence. Today, science has given it a name and a deeper meaning: the Milky Way galaxy. This vast structure is not just a beautiful sight, it is our cosmic home. The Milky Way is a gigantic collection of stars, planets, gas, dust, and mysterious dark matter, all bound together by gravity. It is the galaxy that contains our solar system, including the Earth, the Sun, and every familiar object in our night sky. While it may appear calm and unchanging from our limited perspective, the Milky Way is in constant motion, shaped by powerful forces over billions of years. Understanding it allows us to better understand where we come from and how the universe itself evolves. In the broader context of the universe, the Milky Way is just one of hundreds of billions of galaxies. Some are larger, some smaller, some older, and some still forming. Yet, for humanity, the Milky Way holds a special role. It is the laboratory in which astronomers test theories about star formation, galactic dynamics, and the potential for life beyond Earth. Every discovery within our galaxy helps scientists build models that apply to galaxies across the universe. Earth's position within the Milky Way is both ordinary and extraordinary. On one hand, our solar system is not located near the center, nor in any particularly dramatic region. We orbit quietly in one of the galaxy's spiral arms, far from the violent events near the core. On the other hand, this relatively stable location may be one of the key reasons life was able to develop and survive on our planet. Studying our position helps scientists explore the connection between galactic environments and habitability. Despite centuries of observation, the Milky Way remains difficult to study as a whole. Because we are located inside it, we cannot simply take a picture of our galaxy from the outside. Instead, astronomers must piece together its structure using radio waves, infrared light, and complex computer models. This challenge makes the Milky Way both familiar and mysterious, known in detail, yet never fully seen. The purpose of this presentation is to explore the structure, characteristics, and fascinating facts about the Milky Way galaxy. We will begin with a general overview, explaining what kind of galaxy it is and how large it truly is. Next, we will examine its internal structure, including the galactic center, spiral arms, and surrounding halo. We will then focus on the position of our solar system and the motion of stars within the galaxy. In addition, this presentation will discuss how the Milky Way formed and how it continues to evolve. We will also look toward the future, including the predicted collision with the neighboring Andromeda galaxy. Finally, we will explore surprising discoveries, unanswered questions, and the scientific importance of studying our galaxy in the search for knowledge, and possibly life beyond Earth. By the end of this presentation, you will not only have a clearer understanding of what the Milky Way is, but also a deeper appreciation of humanity's place within it. The Milky Way reminds us that while we are small in the scale of the universe, we are also deeply connected to its grand and ongoing story. To understand our place in the universe, it is essential to first answer a fundamental question. What is the Milky Way galaxy? At its most basic level, the Milky Way is a massive gravitational system that contains stars, planets, gas, dust, and dark matter. All of these components are bound together and move through space as a single cosmic structure. The Milky Way is not static, it is dynamic, constantly evolving over billions of years. The Milky Way belongs to a category known as a galaxy, which is a vast collection of stars and interstellar material held together by gravity. Galaxies come in many shapes and sizes, including elliptical, irregular, and spiral forms. Based on extensive observations, astronomers classify the Milky Way as a barred spiral galaxy. This means it has a central bar-shaped structure made of stars, from which spiral arms extend outward like curved ribbons. This classification is significant because it helps scientists understand how stars move within the galaxy and how the galaxy itself formed. In barred spiral galaxies, the central bar plays an important role in guiding the motion of stars and gas, often influencing star formation in the spiral arms. Observations from infrared and radio telescopes have confirmed that the Milky Way possesses this bar structure, even though it is difficult to see directly due to dense clouds of dust blocking visible light. In terms of size, the Milky Way is enormous beyond everyday human comprehension. Its diameter is estimated to be about 100,000 light-years, meaning that light, traveling at nearly 300,000 kilometers per second, would take 100,000 years to cross from one edge of the galaxy to the other. The thickness of the galactic disk is much smaller, averaging around 1,000 light-years, giving the Milky Way a flattened, disc-like shape. The total mass of the Milky Way is another remarkable feature. Scientists estimate that its mass is equivalent to roughly 1 trillion times the mass of the Sun. However, only a small portion of this mass comes from visible matter such as stars and planets. A significant percentage consists of dark matter, an invisible substance that does not emit or absorb light but exerts gravitational influence. Without dark matter, the Milky Way would not have enough gravity to hold itself together. One of the most fascinating aspects of the Milky Way is the sheer number of stars it contains. Astronomers estimate that there are between 100 billion and 400 billion stars within our galaxy. These stars vary widely in size, age, temperature, and brightness. Some are much larger and hotter than the Sun, while others are small, dim red dwarfs that burn their fuel slowly over trillions of years. Around many of these stars are planetary systems, much like our own solar system. Recent discoveries suggest that planets may be extremely common in the Milky Way. Studies using space telescopes such as Kepler have shown that many stars host at least one planet, and some may have dozens. This has led scientists to estimate that the Milky Way could contain tens of billions of planets, including potentially habitable ones. The galaxy is not evenly populated. Stars are more densely packed near the center and within the spiral arms, while regions farther out are more sparsely populated. In some areas, stars form in clusters, born from collapsing clouds of gas and dust. In other regions, ancient stars drift quietly, having formed billions of years ago in the early stages of the galaxy's history. The Milky Way is also part of a larger cosmic structure known as the Local Group, a collection of more than 50 galaxies bound together by gravity. Within this group, the Milky Way and the Andromeda Galaxy are the two largest members. Their gravitational interaction will play a major role in the future evolution of our galaxy, a topic that will be discussed in later chapters. In summary, the Milky Way is a vast, complex, and dynamic galaxy, a barred spiral system of immense size and mass, filled with hundreds of billions of stars and potentially even more planets. This general overview provides the foundation for understanding the galaxy's structure, motion, and significance. With this context in mind, we can now explore the internal architecture of the Milky Way and uncover how its individual components work together to form our cosmic home. The Milky Way galaxy may appear as a simple band of light in the night sky, but in reality, it has a complex and layered internal structure. Astronomers divide the galaxy into several major components, each with distinct physical characteristics and functions. Understanding these components helps explain how the Milky Way formed, how it behaves today, and how it continues to evolve over time. At the heart of the Milky Way lies the galactic center, also known as the galactic center. This region is located approximately 26,000 light-years away from the solar system, in the direction of the constellation Sagittarius. It is an extremely dense and energetic area, containing a high concentration of stars, gas clouds, and exotic objects. Due to thick interstellar dust, the galactic center cannot be observed easily using visible light. Instead, astronomers rely on infrared, radio, and X-ray observations to study it. One of the most significant discoveries in the galactic center is the presence of a supermassive black hole, known as Sagittarius A star. This black hole has a mass equivalent to about 4 million suns. Although black holes themselves emit no light, their presence is revealed by the rapid motion of nearby stars orbiting an invisible central mass. Sagittarius A* plays a crucial role in shaping the dynamics of the inner galaxy, influencing the movement of stars and gas in its vicinity. Surrounding the galactic center is the galactic disk, the most visually striking part of the Milky Way. The disk is a flattened, rotating structure that contains most of the galaxy's stars, gas, and dust. Embedded within the disk are the Milky Way's famous spiral arms, which curve outward from the central bar. These arms are not rigid structures but rather regions of higher density, where gas and dust are compressed as they orbit the galaxy. The spiral arms are especially important because they are sites of active star formation. As clouds of gas and dust collapse under gravity, new stars are born, often in clusters. These young stars tend to be hot and bright, giving the spiral arms their luminous appearance. In contrast, older stars are more evenly distributed throughout the disk and are less concentrated in the arms. Astronomers have identified several major spiral arms in the Milky Way, including the Perseus arm, the Scutum Centaurus arm, and the Sagittarius arm. The solar system is located in a smaller structure known as the Orion arm or Orion spur, which lies between two of the major arms. This position provides a relatively stable environment, away from the intense radiation and gravitational disturbances found closer to the galactic center. Beyond the disk lies the galactic halo, a vast, roughly spherical region that surrounds the entire galaxy. The halo contains relatively few stars, but those that do exist are among the oldest known in the Milky Way. These ancient stars provide valuable clues about the early stages of galactic formation. The halo is also home to globular clusters, tightly bound groups of hundreds of thousands of stars that orbit the galactic center. Perhaps the most mysterious component of the halo is its large amount of dark matter. Although invisible, dark matter makes up a significant portion of the galaxy's total mass. Its gravitational influence helps explain why stars in the outer regions of the Milky Way orbit at unexpectedly high speeds. Without dark matter, the galaxy would not have enough mass to remain gravitationally stable. Another essential element of the Milky Way structure is the presence of interstellar gas and cosmic dust. These materials are found primarily in the disk and spiral arms, forming vast clouds known as nebulae. Gas, mainly hydrogen and helium, serves as the raw material for star formation. Dust, made of tiny solid particles, plays a crucial role in cooling gas clouds and shielding newly forming stars from intense radiation. While dust is essential for star formation, it also creates challenges for astronomers. Dust absorbs and scatters visible light, obscuring large portions of the galaxy from view. This is why modern astronomy relies heavily on non-visible wavelengths, such as infrared and radio waves, which can penetrate dust clouds and reveal hidden structures. In summary, the Milky Way is composed of several interconnected components: a dense and energetic galactic center, a rotating disk filled with spiral arms, a vast and ancient halo, and immense quantities of gas, dust, and dark matter. Each part contributes to the galaxy's overall behavior and evolution. By studying this structure, scientists gain insight not only into our own galaxy but also into the fundamental processes that shape galaxies throughout the universe. And complex, humanity's story unfolds in one very small corner of it. The solar system, which includes the Sun, Earth, and all the planets, occupies a specific and meaningful position within the galaxy. Understanding this location helps explain not only how our planetary system moves through space, but also why Earth has been able to support life for billions of years. The Sun is located in a region known as the Orion Arm, sometimes called the Orion Spur. This is a minor spiral arm situated between two of the Milky Way's major spiral arms, the Sagittarius Arm and the Perseus Arm. Unlike the dense and dramatic central regions of the galaxy, the Orion Arm is relatively quiet. It contains a moderate number of stars and fewer violent events such as supernova explosions, making it a more stable environment for planetary systems. Our position in the Orion Arm is not at the center of this structure but somewhat off to the side. The Sun orbits the galactic center along with billions of other stars, maintaining a roughly circular path within the galactic disk. From this location, we have a clear but limited view of the galaxy. Dense dust clouds prevent us from seeing the galactic center directly with the naked eye. While our position inside the disk means we can never observe the Milky Way from the outside. The distance between the solar system and the galactic center is approximately 26,000 light-years. While this may seem enormous, it places us about halfway between the center of the galaxy and its outer edge. This location is often described as part of the galactic habitable zone, a region where conditions are favorable for the development of life. Closer to the center, intense radiation and gravitational disturbances could disrupt planetary systems. Farther out, there may be too few heavy elements necessary for forming rocky planets. The Sun does not remain stationary as it orbits the galaxy. It travels at an average speed of about 220 kilometers per second. Even at this incredible velocity, a single orbit around the galactic center takes an extremely long time. This period is known as a galactic year, and it lasts approximately 225 to 250 million Earth years. Since its formation around 4.5 billion years ago, the Sun has completed only about 20 galactic orbits. This fact highlights just how slowly large-scale cosmic processes unfold compared to human timescales. Entire civilizations rise and fall in a tiny fraction of one galactic year, emphasizing the contrast between human history and cosmic time. The solar system's orbit is not perfectly smooth. As it moves through the galaxy, it gently oscillates up and down through the galactic disk, passing through regions with slightly different star densities. Some scientists suggest that these movements may have influenced Earth's geological and biological history, possibly correlating with long-term climate changes or extinction events. However, this idea remains an area of ongoing research and debate. Another important aspect of our location is its relative isolation. The nearest star system to the Sun, Alpha Centauri, is more than 4 light-years away. This vast distance between stars reduces the likelihood of close stellar encounters that could disrupt planetary orbits. Such stability may be a key factor in the long-term survival of life on Earth. Despite being in a calm region, the solar system is not completely shielded from galactic events. Over millions of years, it has been exposed to cosmic radiation, passing shockwaves from distant supernovae, and gravitational influences from nearby stars. These interactions remind us that even in a stable neighborhood, the galaxy remains an active and interconnected system. In summary, the solar system occupies a carefully balanced position within the Milky Way, far enough from the chaotic center to avoid extreme danger, yet close enough to benefit from the rich chemical environment needed for planet formation. Our location in the Orion Arm, our distance from the galactic center, and our long, steady orbit around it have all contributed to the conditions that made life on Earth possible. Understanding where we are in the galaxy deepens our appreciation of both our vulnerability and our extraordinary place in the universe. The Milky Way galaxy may appear calm and unchanging when viewed from Earth, but in reality, it is a system defined by constant motion and long-term evolution. Every star, planet, and cloud of gas within the galaxy is in motion, responding to gravitational forces that have shaped the Milky Way over billions of years. Understanding this movement allows scientists to reconstruct the galaxy's past and predict its future. At the largest scale, the Milky Way rotates around its center. Unlike solid objects, the galaxy does not rotate as a single rigid body. Instead, different regions move at different speeds, a phenomenon known as differential rotation. Stars closer to the galactic center complete their orbits faster than those farther out. This behavior plays a major role in shaping the spiral structure of the galaxy. The Sun, for example, travels around the galactic center at a speed of approximately 220 kilometers per second. Stars closer to the center move even faster, while stars in the outer regions move more slowly. However, observations show that beyond a certain distance, orbital speeds remain surprisingly constant rather than decreasing as expected. This unexpected pattern was one of the strongest pieces of evidence for the existence of dark matter, which provides additional gravitational force. The spiral arms of the Milky Way are not permanent structures made of the same stars. Instead, they are regions of higher density that move through the disk like slow-moving waves. As stars and gas pass through these regions, gas clouds are compressed, triggering bursts of star formation. Once stars move out of the arm, they continue their journey around the galaxy independently. This explains why spiral arms appear bright and well-defined without remaining fixed. Beyond rotation, the Milky Way also experiences motion on a larger cosmic scale. The entire galaxy is moving through space as part of the local group, influenced by the gravitational pull of neighboring galaxies. The most significant of these neighbors is the Andromeda Galaxy, which is currently moving toward the Milky Way at a speed of about 100 kilometers per second. This motion leads to one of the most dramatic predictions in galactic astronomy: a future collision between the Milky Way and Andromeda. Based on current measurements, this event is expected to occur in approximately 4 to 5 billion years. While the word collision may sound catastrophic, individual stars are unlikely to collide due to the vast distances between them. Instead, the galaxies will gradually merge, reshaping their structures over billions of years. Looking back in time, astronomers believe that the Milky Way formed over 13 billion years ago, shortly after the birth of the universe. In its early stages, the galaxy was much smaller and more chaotic. It grew through the gradual accumulation of gas and the merger of smaller galaxies. Evidence of these past mergers can still be seen today in the form of stellar streams, long trails of stars that once belonged to smaller galaxies absorbed by the Milky Way. Star formation within the Milky Way has not been constant. Periods of intense activity have alternated with quieter phases. Today, the galaxy forms a few new stars each year, a relatively modest rate compared to its early history. Over time, as gas supplies are depleted, star formation is expected to slow further, gradually changing the galaxy's appearance. The evolution of the Milky Way is also influenced by powerful events such as supernova explosions and stellar winds. These processes recycle material back into the interstellar medium, enriching it with heavier elements. These elements are essential for forming planets, and ultimately, life. In this way, the death of stars contributes directly to the birth of new ones. In summary, the Milky Way is a galaxy in motion, rotating, evolving, and interacting with its cosmic environment. From its early formation to its predicted merger with Andromeda, the galaxy's story is one of continuous change over immense timescales. Studying this motion and evolution not only reveals the past and future of our galaxy, but also helps scientists understand the life cycles of galaxies throughout the universe. Despite being humanity's home galaxy, the Milky Way is full of mysteries and surprising discoveries. Many of its most fascinating features challenge common assumptions and remind us how much remains unknown. As technology improves, scientists continue to uncover facts that reshape our understanding of the galaxy and our place within it. One of the most remarkable discoveries is the existence of a supermassive black hole at the center of the Milky Way, known as Sagittarius A*. This object has a mass millions of times greater than the Sun. Although black holes are often imagined as destructive forces, Sagittarius A* is currently relatively quiet. It does not actively consume large amounts of matter, allowing the inner regions of the galaxy to remain stable. This challenges the popular image of black holes as constant cosmic threats. Another surprising fact is that the Milky Way is far from a static structure. Over long periods of time, the galaxy changes shape as stars move, spiral arms shift, and smaller galaxies are absorbed. Astronomers have discovered streams of stars that stretch across the sky, remnants of dwarf galaxies that were torn apart by the Milky Way's gravity. These stellar streams act as historical records, revealing past galactic mergers that occurred billions of years ago. The Milky Way is also far larger than what we can see with the naked eye. While visible stars form the familiar glowing band in the night sky, they represent only a small fraction of the galaxy's total mass. A massive halo of dark matter surrounds the galaxy, extending far beyond the visible disk. Although dark matter cannot be observed directly, its gravitational effects are essential for explaining how the galaxy holds together. Perhaps one of the most intriguing topics related to the Milky Way is the possibility of life beyond Earth. With hundreds of billions of stars and potentially even more planets, the galaxy offers countless environments where life might exist. Astronomers have already identified thousands of exoplanets, some of which lie within their star's habitable zone, where liquid water could exist. While no confirmed evidence of extraterrestrial life has been found, the sheer scale of the Milky Way makes the idea scientifically plausible. Another lesser-known fact is that we cannot see the Milky Way clearly from Earth at all times. Light pollution, atmospheric conditions, and interstellar dust significantly limit observation. In many urban areas, the galaxy is completely invisible to the naked eye. This means that for much of the world's population, the Milky Way exists only in photographs or scientific data, rather than as a direct visual experience. The Milky Way also emits energy across the entire electromagnetic spectrum. While our eyes detect only visible light, the galaxy produces radio waves, infrared radiation, X-rays, and gamma rays. Each wavelength reveals different features, from cold gas clouds to violent high-energy events. Modern astronomy relies on this multi-wavelength approach to build a more complete picture of the galaxy. There are also many aspects of the Milky Way that scientists have not yet observed directly. For example, the full shape of the galaxy's spiral arms is still being refined, and the exact distribution of dark matter remains uncertain. Even the total number of stars is an estimate rather than a precise measurement. These uncertainties highlight the limits of current technology and the challenges of studying a galaxy from within. In summary, the Milky Way is a galaxy full of surprises, dynamic rather than static, largely invisible rather than fully seen, and rich with possibilities rather than simple answers. Each new discovery deepens our sense of wonder and reminds us that even in our own cosmic backyard, there is still much to explore. The Milky Way galaxy is more than just the setting of our existence. It is one of the most important objects of study in modern astronomy, because we live inside it. The Milky Way provides scientists with an unparalleled opportunity to observe galactic processes in great detail. Knowledge gained from studying our galaxy serves as a foundation for understanding galaxies throughout the universe. One of the primary scientific values of the Milky Way lies in its role as a natural laboratory. Astronomers can study stars at different stages of their life cycles, from newly formed protostars to ancient stellar remnants. These observations help scientists refine models of stellar evolution and test theories that cannot be examined directly elsewhere. The proximity of many stars allows for precise measurements of distance, motion, and composition. The Milky Way is also central to research on dark matter. Because the galaxy's rotation curve can be measured accurately, astronomers can infer the presence and distribution of dark matter within and around it. These findings are essential for cosmology, as dark matter plays a crucial role in the formation of galaxies and the large-scale structure of the universe. Without studying our own galaxy in detail, many of these theories would remain purely theoretical. Another major area of significance is the search for exoplanets and extraterrestrial life. The Milky Way contains an enormous number of stars similar to the Sun, many of which host planetary systems. By studying nearby stars, scientists can detect planets, analyze their atmospheres, and evaluate their potential habitability. This research directly addresses one of humanity's oldest questions: are we alone in the universe? Despite these advantages, observing the Milky Way also presents unique challenges. Interstellar dust blocks visible light, making large regions of the galaxy difficult to study. Additionally, because we are located inside the galactic disk, we cannot observe the Milky Way's overall shape directly. Astronomers must rely on indirect methods, combining data from multiple wavelengths and complex simulations to construct accurate models. To overcome these limitations, scientists have developed advanced observational tools and missions. Space telescopes such as Hubble and James Webb allow astronomers to observe the galaxy in wavelengths that penetrate dust clouds. Radio observatories map hydrogen gas across vast distances, revealing the galaxy's spiral structure. Meanwhile, the Gaia mission has revolutionized our understanding by precisely measuring the positions and motions of more than 1 billion stars. Future missions promise even greater insight. Next-generation telescopes will provide higher resolution and sensitivity, enabling the detection of fainter objects and more distant phenomena. Advances in data processing and artificial intelligence will also play a key role, allowing scientists to analyze enormous datasets more efficiently and uncover patterns that were previously invisible. The scientific importance of the Milky Way extends beyond pure research. Discoveries about our galaxy influence technology, education, and our philosophical understanding of the universe. By learning how galaxies form and evolve, humanity gains perspective on its own origins and long-term future. This knowledge fosters a sense of curiosity and encourages international collaboration in science. In summary, the Milky Way is central to modern astronomy, offering both extraordinary opportunities and significant challenges. Through continuous observation and technological innovation, scientists are gradually unveiling its secrets. Each new discovery brings us closer to understanding not only our galaxy, but the universe as a whole. Throughout this presentation, we have explored the Milky Way galaxy from multiple perspectives, gradually building a comprehensive understanding of our cosmic home. From its basic definition to its complex internal structure, and from the position of our solar system to the galaxy's motion and future evolution, the Milky Way emerges as a vast, dynamic, and deeply fascinating system. We began by introducing the Milky Way as a barred spiral galaxy containing hundreds of billions of stars and potentially even more planets. Its immense size and mass place it among the larger galaxies in the universe, while its composition, stars, gas, dust, and dark matter, reveals the intricate balance of forces that hold it together. Understanding these fundamental characteristics provides the foundation for all further study. We then examined the structure of the Milky Way, including its dense galactic center, rotating disk, spiral arms, and extended halo. Each component plays a distinct role in the galaxy's behavior and evolution. The presence of a supermassive black hole at the center, the active star formation within spiral arms, and the mysterious influence of dark matter all highlight the complexity hidden behind the galaxy's serene appearance. A key focus of the presentation was the position of our solar system, located in the relatively calm Orion Arm, far from the galactic center. Earth benefits from a stable environment that may have allowed life to develop and persist. The long galactic orbit of the Sun reminds us that cosmic timescales far exceed human history, placing our existence within a much larger temporal framework. We also explored the motion and evolution of the Milky Way, discovering that the galaxy is constantly changing. From its early formation through mergers and gas accumulation to its predicted future collision with the Andromeda Galaxy, the Milky Way's story is one of continuous transformation. These processes connect our galaxy to the broader evolution of the universe. Finally, we considered the scientific significance of the Milky Way and the future of its exploration. Despite technological limitations, modern missions and advanced telescopes have greatly expanded our knowledge. Ongoing research into dark matter, exoplanets, and galactic dynamics continues to push the boundaries of what we can observe and understand. In conclusion, the Milky Way is not merely a distant astronomical object. It is the environment that shaped our origins and continues to influence our future. Studying it deepens our understanding of the universe and our place within it. At the same time, the many unanswered questions surrounding the Milky Way invite curiosity and inspire future generations to explore, discover, and expand the horizons of scientific knowledge. As we come to the end of this presentation, we can see that the Milky Way galaxy is far more than a collection of stars in the night sky. It is a complex and evolving system that has shaped the past, present, and future of our solar system. Through the 8 sections of this presentation, we have learned about the structure of the Milky Way, the motion of its stars, the special position of our solar system, and the scientific discoveries that continue to expand our understanding of the universe. Each part reveals how closely connected our existence is to the larger cosmic environment. Although much about the Milky Way remains unknown, this sense of mystery is what drives scientific exploration forward. Every new discovery brings us one step closer to understanding our place in the universe. In conclusion, studying the Milky Way reminds us that while humanity is small on a cosmic scale, our curiosity is limitless. The galaxy above us is not just something to observe, it is a reminder to keep exploring, questioning, and learning. Thank you for your attention.